All right, Chem. Today we're going to review a little bit about percent composition. So when you have percent composition of a compound, you're really talking about breaking it down into how much of each individual element is in there. So I'm going to start with calcium bicarbonate or calcium hydrogen carbonate. You'll hear it called sometimes too. This is an antacid. It's the active ingredient in things like Tums, and it has other medicinal uses too. So it's actually an important substance. So in order to get the percent composition, we first add up the individual elements. There's 1 calcium. There's 2 hydrogens because this 2 gets distributed out to each of the elements in the polyatomic ion, bicarbonate polyatomic ion. There's also 2 carbons, and there's 2 times 3 or 6 oxygens. So we're going to go to the periodic table of the elements and find the individual elements' masses, like such. So when you add those up, and I'm not going to round to significant figures until I'm done, I get 162.116 grams per mole in calcium bicarbonate. If I was going to round it to 4 sig figs, which is what I would need to do, it'd be 162.1. So now let's talk about the percent of each. So the percent calcium is going to be the part that's calcium over the whole compound. So the part calcium is 40.08 over the whole compound is 162.116. In order to turn it into a percent, we multiply by 100. So I'm going to multiply this all through, and I get 24.72% calcium. I'm going to round to 4 sig figs for our purposes here, so I don't end up writing down a bunch of digits. And then let's go individually and do each one of these. So the part that's hydrogen is 2 times 1.008 over the whole 162.116. And that gives me 1.243% hydrogen. Again, I'm just going to round to 4 sig figs. This time we have 6 oxygens. For 96 total grams. And that gives us 59.22% oxygen. Now, if you want to check that you've done everything correctly, you can add up each of the percentages, and everybody knows that all of the percentages should add up to 100. Now, because we've done some rounding, it might not be exactly 100, but it should be really close to 100. So this is my percent composition of this particular compound. Now, you can use the way we did the combustion analysis originally. That's acceptable, but this is another way to solve combustion analysis problems if it works better for you. We're going to use this concept in our next lab also. So 2.5, let's say you had 2.5 grams of calcium bicarbonate. In order to get how much of each there are in there, you can do a stoichiometry problem like we learned first. Now we're going to learn a different way. So if we had 2.5 grams of calcium bicarbonate, we could multiply it by the percent as a decimal, Let's just do a couple of them. Let's do oxygen. 0.5922. That's the part that's oxygen. 59.22% is 0.5922 out of 1. And that gives me 1.4805 grams of oxygen. I'm not going to bother rounding to sig figs. Let's do one more. 2.5 grams of calcium bicarbonate contains 1.243% hydrogen. So as a decimal, that's 0.01243. Don't forget to move it over twice for 0.031075 grams of hydrogen. So you can get the percent composition in order to figure out which part of it is each individual atom, depending on what they ask you for, or you can do stoichiometry. There's also other ways to do this, but this is how you do percent composition. So if this is not coming back to you from first year, you better do some example problems on how to calculate percent composition.